Right. This is an introduction to graphing rational functions. So our most basic rational function, or what is a rational function? A rational function um, is basically made of two parts. We can call this P of X. We can call this Q of X on the bottom. So it's basically a fraction where you have two polynomials. So P of X is a polynomial. Q of X is a polynomial. So for example, if P of X equals 1, right, that's a function. That's a polynomial. Not a great example of a polynomial, but it's a polynomial. And then Q of X equals X. So a rational function, we can write P of X over Q of X. So we could write that as 1 over X. Right, other examples, if we look here, right, 2 over X minus 3. Those would be examples of rational functions. So our most basic rational function here is 1 over X. So I want to take a look at that on the graph. So I'm going to go over to Desmos here, and I have it graphed for us. F of X equals 1 over X. Okay. Maybe I should have done F of X instead of G of X. So we're going to change this to F of X. Okay. So the first thing I want to point out is our graph has two asymptotes. So an asymptote is a line. It's not part of the graph, but it's a line that the graph approaches but does not touch. It doesn't cross or intersect. It might cross or intersect at other parts, but at the end, on the ends, on the right and the left, or the top and the bottom, up and down, it doesn't touch. So if we look here, we have a horizontal asymptote, right? And that is the x-axis. Okay. And we have a vertical asymptote, and in this case, it is the y-axis. Okay, and we notice, right, the graph gets closer and closer, but it never touches. So if we zoom in and look at it, right, as we go to the right and the left, right, we zoom in maybe here at 42, right, we notice it's getting closer to that x-axis, but it never quite touches, right? And you can zoom out and go all the way down, you know, to 106, and you zoom in and you notice the graph's getting closer and closer to that x-axis, but it never touches, it never intersects. So that's what an asymptote is. It's the line that the graph approaches, but never reaches. Okay. So that's the parent function 1 over x. Let's look and see what happens here if we subtract 4 from 1 over x. So if we do minus 4, we notice that our graph is shifted down 4. So now our asymptote, instead of being the x-axis, is now the line y equals -4. It got shifted down 4, and the x-axis, or the y-axis, the horizontal or the vertical asymptote stayed the same. Okay. Again, we don't want to delete everything, just that. Okay, let's look. Instead of shifting down 4, if we put x plus 2, we notice that our graph gets shifted 2 to the left. So now instead of our vertical asymptote being the y-axis, our vertical asymptote is the vertical line, x equals 2. Okay. If we put a 4 on top instead of 1 over x, we notice we have a stretch. The graph is getting expanded out. Notice how instead of the point 1, 1, we have the point 1, 4, right? It's getting 4 times as far away from that x, that x-axis, 4 times as far away. Okay, and then the last one here we have is if there's a negative in front of our function. So it's -1 over x. We notice it's going to switch. So if it's positive 1 over x, it's going to be in the top right and bottom left. If it's negative, it's in the top left and bottom right. So positive, and then the purple here would be negative. Okay, so our components here, you know, the k outside, right? So as an example over here, that's our horizontal asymptote. So y equals k. Our vertical asymptote is x equals h. So it's whatever is in the denominator, whatever makes the denominator 0. Okay, the value of x that makes the denominator 0 is one way to think of it, or you can think of it as h. And then A is our vertical stretch. So example here, we had a vertical stretch of 4. Okay, let's look at some examples now. Okay, let me go over to the problems. Okay, example 1. So if we look here, we have a horizontal stretch. I probably shouldn't be using yellow. We have a horizontal stretch, a horizontal asymptote at 4, right? The K. So I'm going to do y equals 4. Okay, and then my vertical asymptote is going to be h here, which is x minus 3. So my vertical is 3. X equals 3. I can also do this by solving the denominator for 0. So I can write x minus 3 equals 0 and solve for x. I add 3 and I get x equals 3, right? So that gives me, if I substitute in 3 for x, I'm going to get 3 minus 3, which is 0. And 2 over 0 doesn't work. I can't have 2 over 0 because I can't have a 0 in the denominator. So that's why we're going to put 3 there. Okay, and then the last thing, we're going to have a stretch of 2. And since A is positive, it's a positive 2. Our graph is going to be in the top right and the bottom left. Okay, if we go ahead and graph this, then I'm going to start by plotting my asymptotes. So I'm going to put a vertical asymptote at 3. I'm going to put a dashed line here at 3. Right, and then a horizontal asymptote at y equals 4. So I'm going to put a horizontal asymptote here at y equals 4. Okay, and then since this is positive, right, I can do it top right, bottom left. So I'm going to graph here and here, and then here and here. And again, it gets closer and closer and closer, closer and closer and closer, but it never touches those asymptotes. Okay. If I were to do domain and range, my domain, right, is going all the way from the left, negative infinity, up until 3. And then again, it picks up after that asymptote, 3 to infinity. Okay, and range, you start all the way at the bottom, you go up until you get to 4. So my range is going to be negative infinity until 4. And then it doesn't hit 4, it just pops up on the other side. So that's going to be 4 to infinity, all the way up. Okay. All right, let's look at the next one. Oh, that dash line will take a lot to erase. Okay. So if we look at this one, we're going to have, again, a horizontal asymptote at 4. So it's going to be y equals 4. A vertical asymptote this time is going to be negative 2. Again, I can do this 2 ways. I can think of x plus 2 as x minus negative 2. So it fits my equation. X minus negative 2. Or I can think of it as what value of x is going to make my denominator, x plus 2, equal to 0. And that value is going to be negative 2. Negative 2 plus 2 gives me 0. So I can't have negative 2 for x because it gives me that 0 in the denominator. Okay, and then the graph, I'm going to plot those asymptotes. So negative 2 is my vertical. And 4 is my horizontal. Okay, this is negative. So when I graph it, it's going to look like this. And like this. Right? Because it is negative. And we don't need to worry about the domain and range. All right, let's look at one more. Okay. Horizontal asymptote is going to be y equals 1. Vertical asymptote, this is a little more challenging because you have 2x minus 4. So we need to find when does 2x minus 4, for what value of x will that give me a 0 in the denominator here? So 2x minus 4 equals 0. I'm going to add 4 to both sides. And I get 2x equals 4. I divide by 2 and I get x equals 2. Okay, so I have a vertical asymptote at 2. And a horizontal asymptote at 1. Since this is negative, right, I'm going to go top left and bottom right. Right, again, if it was positive, it would look like this. Since it's negative, we got to switch it as such. Okay, let's move over to some